Now coming to second timestamp, because it is a sequential process, so once this has happened, it will also this will be simultaneously happen. And again you will see how we can simultaneously create this. Actually one of the problem is like this only, this is like time consuming LSTM GR. So what we use, CUDA CNN we use, so that parallel processing we can do, NVIDIA CUDA CNN. But again that's a topic for some other day. So here once in timestamp 1 we are going to pass some other input. Again the same workflow goes, and we are going to use the output which we have got h1, because for h2 ht minus 1 will be h1. So whatever the output we will get, we will use that, we will add this weight here, and that again we that will fetch you h2, which will be used for y2 calculations. So this process goes on like that. So this is the forward propagation. So basically forward propagation, nothing fancy, we are just using equations and we are propagating from left to right, as you can see, from timestamp 0 to timestamp t. But so backward propagation, how happens, that we will see in detail obviously now in depth a little bit. But to give you a gist, here as you can see loss LT, that means loss at timestamp 1, that will be propagated like this. That loss will be propagated something like this to all this U weights and W weights. Now loss at timestamp 2, that will be propagated obviously like this, and also backward propagation through time, it will also pass this direction also. So this will pass something like this, and it will also back propagate to L1 also, not L1, timestamp 1. So it will go over here, W's and here. So that we'll see how it happens. So this is actually the flow which I want to explain, that I will again tell you in the coming part. So loss for now at y1, it is, we are just using binary cross entropy loss for 2 class levels for suppose. But for our AirSketch problem, RNN, this plays a major role. RNN, we use bidirectional LSTMs, CNN bidirectional LSTMs, and then we will use CTC loss and then beam search. So has LSTM bidirectional LSTM, for that RNN should be base. So we are just covering this, and for any other project also this can be a base. So for now binary cross entropy loss, for if just for example, simple example, so this will be thing where we can see that yt minus of yt into product with log of yt hat. So here as you can see, this is actual class and this is prediction class. So with that we will get loss, and we can also get the loss total as sum of all those losses here, L1, L2 till LT. And whatever we get the loss, the sum of those will be like loss at L1, that is V, because we are taking loss with respect to V only, because V is the weight which is happen to be in the output. That weight again will be whatever the dl by dv will be propagated to dl by dw also. We will see how, because w, like here as you can see, v yt is dependent on v is independent here, but whatever we get over here, like I'm going to say is w, as you can see, is dependent on, like it gives a value to v, right? Now let me add one more equation. Let us take z as vht product, then yt hat will becomes, this will be z now, softmax of z. Now as you can see, yt depends on z. So here in this equation, z is independent, yt is dependent on z, and the same goes for here in z equation, z is dependent on v and v is independent. And then what happens is like, so if we will find dl by dy hat, so and here this loss should be propagated to dy also, right? But dy in turn is dependent on dz, and dz in turn is dependent on dv. So if you want to calculate dz by dv, we need to calculate these two. What I'm saying is dl by dv, if you want to calculate dl by dv, so we need all these parts. So if you want to calculate with respect to v is the like last, for suppose like from v we are going to generate yt, as you can see, and with yt we can also get loss information, right? So yt then we can get loss. So from loss, if you want to back propagate, we need to get yt, we need to find with respect to yt.